All right, anybody got it in their notes? Okay, what was it? F of X. Memory's full on the diagram. All right, give it to me one more time. F of X. 43. Square root X. 43 square root X. Is that what it was? 43. Say it one more time. I heard everybody. Huh? 40x to the square root X or 43 power. Okay, square root X like that. All right. Thank you. All right, so we've got something raised to an exponent. Now, if you was to rewrite this, you can rewrite it as f of x is equal to 43 to the what? X to the 1/2, right? Now, that's not really going to help you very much, is it? What do we have to do here? What is the rule about natural log? Or what is the rule? The rule says that if you have u du, what is that equal to? The natural log of what? If you have u over du, what is that? The natural log of what? U, right? The it's not the antiderivative, the derivative, right? Let's look at it because some of y'all are going, I'll just pull it up because I can't find y'all on dadgum Webassign. So I'll just pull it up. If you see it, just throw it out there. I'm looking. Let me just do natural log. Natural log. Right in here. If you have y is equal to a to the x, that's going to, you pull it out using the constant rule. Remember the constant rule that you did back in your algebra class? You remember that? You pull this. What can you do with this if you take the natural log of it? You can pull it out. Now that gives you the natural log derivative law. If you actually look at the algebraic law, it'll give you the derivative law. And what is the derivative law? Right here. U du. If u is equal to x, or du over u, sorry, du over u. If u is equal to x, what's the derivative of u? What's the derivative of x? Now, what's the derivative of x? 1. So you have the derivative over the what? Over the function, right? Derivative over the function is what? Natural log of that function. Okay? This goes backwards. The antiderivative, derivative is the same way. So, if you take the derivative of natural log, what will you get? 1 over x. Got it? So, how will that help us? How will that help us with the problem we're doing? How will that help us? You also could use your algebraic law of y is equal to 43x to the 1/2. Y is equal to x to the y. B is equal, or x is equal to a to the y. There you go. X is equal to a to the y, and then you can switch it into the natural log or the log based on the algebraic law. So what can you do? Y'all can talk, can't you? No, you're talking about solving. You're solving. That's what you do when you solve. We're not solving, we're finding the derivative. Does anybody know how to clear the memory on a camera? All right, figure that out next. What do you do with this one? While y'all work on it for a second, I'm going to pull up again the Webassign and see if I can find our book or our class. I don't know why it's not coming up. Y'all did enroll it. Our class is on there, right?
Yeah.
Well, then why can't I find it? My classes. Oh, I bet that's it right there. No. Spring 2015. Class key. Somebody tell me what the class key was. Is it 5998? Okay, so that one, we don't need that one. There it is. This is it. 5652. That's it. Hot dog. We cooking with peanut oil now. I'm not going to do that because they'll take an act to Congress. Believe you me, this happens in all classes. It's not just mine. You're supposed to be able to let me try this again. Sorry. All these computers on the Anderson campus are screwed up. Just restore it. We had one teacher last week get mad at the computer and throw it in the floor. Kind of harsh, don't you think? Sound like they have issues. Sound like a Calc II student stressing out, right? Okay, nobody gonna talk to me. That's alright. I'll remember you. What did y'all say it was chapter 3? Yeah, I guess it's chapter 3. I was just wanting to find that main page. It's got the rules on it. Somebody knows it right quick. Or got it in the book. They give them all separated and then they give them to you on a sheet, on a page. I was just looking for that for y'all. Product and quotient rule, we already covered those. We're getting there. That's the trig rules. I didn't cover that very much, but that's all memorization. Back that up. Chain rule, did we cover that? I think we covered that. I take it y'all don't bring y'all's book to class. Is that correct? Okay, you're not going to talk to me, okay. What'd you say? That's fine, at least you brought a book. But you can't tell me the page. There we go. Hot dog. Right there. Now look at it. Well, blow it up, Hubert. Derivative of natural log. There's your dy dx. Dy dx. That was the u du I was talking about. So we've got right here, we've got the whole conglomeration right here. All right. Now, what do you do with it? Using that rule, we'll use the natural log since we're doing the natural log right there. And we'll take our handy dandy do-jigger there. Y is equal, you could rewrite this. I'm going to show you a trick I learned in the war. This right here is Y. Y is equal to 43 to the X. Don't laugh at my writing. You come up here and write with a mouse. Bet you can't do it. Now, go back to the algebraic rule. What is your algebraic rule that changes a exponent into a logarithm? It's called the definition of a logarithm. Y is equal to what? Y is equal to log base A of what? Of X. And that's equal to what? X is equal to A to the Y, right? Y'all remember that? Look it up. So, if I've got this, can I rewrite this as a logarithm? Or this as a logarithm? Okay, rewrite it as a logarithm. Okay, so this X is equal, now they got it a little bit backwards. That's equal to X. What's A? A is 43. And Y is what? That's Y, sorry. So now I'm going to say X to the 1/2 is equal to what? Log base what? Of, or I might have the X and the Y backwards, but now you got a logarithm or a natural log, it doesn't matter. Now what do you do with the natural log? Well, you take the derivative of it. Now if you need the definition of a logarithm, all you got to do, go to your handy dandy website or Google definition of a logarithm. Dang old, just do the images so you can see it right quick. Dang old right there. And write it 2 or 3 different ways. Y is equal to log base A of X. Is that the way I had it? I hope I did. Y is equal to log base A of X. And X is equal to B to the Y, or A to the Y. X is equal to A to the Y. So what do you do with this guy? Well, is that log base 43? Can you take log base 43 in your calculator? No, Hubert. That's right, class. You can. Why? Because what's the only log you can take in your calculator? Base 10 or base E, which is natural log. So we got to change that to a change base formula. You don't have to. You solve it. You do. So what do you do next? Have y'all not seen one of these problems before? What do you do? You don't have to think. It's like Jeopardy. Now that you got it in terms of a logarithm, go ahead and finish it. Are you sure this problem was 43x to the 1/2, or was it natural log of 43x to the 1/2? It was 43x to the 1/2? Okay, I was just making sure. Just making sure. Now you could pull the the x to the 1/2 out. You could pull that out and then take the x to the 1/2 times the natural log of 43. I think that's going to be your final answer.
You have to take a natural log of both sides. And then, like a natural log of x, natural log of 43, the square root of x. Bring the square root of x out. And then take the derivative of both sides. So you would have 1 over y, dy or y prime. And then you would have...
you use an implicit.
Yeah.
Okay, you can use implicit. You can do that. I was trying to find our worksheet that we was using the other day, but I can't find it. Did I call it review, Calc I, review, worksheet? Y'all remember what I called it? I can't remember which one I clicked on. Oh well. I'm not going to worry about it. You could do it that way. You're going to get the same answer no matter what you do. f of x, or y, is equal to 43 x to the 1/2, like that. And you can take the natural log of both sides. Natural log of y is equal to natural log of 43 x to the, and this, you're going to take natural log of y, and y prime is equal to the derivative of the natural log of 43 x to the 1/2 prime. And then what do you get over here? 1 over y. But you got to do 1 over y times what? Y prime equals, and then this is going to come out. You can bring this out. And that would be x to the 1/2. I hadn't done the derivative yet. I'm just bringing this out because this is the rule. You can bring this out, and then you got the what? What is this right here? Product rule. And then you can do it long way if you wanted to. It's gonna cancel out, yes. But what I'm saying is you can do it either way. And that's the good thing about two things. What do exponents and logarithms have in common? Anybody know? Come on now, y'all are second semester calculus students. What do they have in common? They're both what? One's glorified exponent or exponent on steroids, the other one's the exponent. Alright? Both of them are exponents. What do you know about exponents from algebra when dealing with an equation or anything having to deal with exponents? You can do them how many different ways? 3 or 4 different ways. Now, you add derivatives in there with the product rule, the quotient rule, and the power rule. You can do them several different ways that way. So you've got a lot of different ways that you can do it. But the answer will come out what? The same. And we get 1 over y, we're going to multiply by this side by what? Y over 1. And y prime is going to be equal to, what does this come out to be? It's going to be x to the negative 1/2. Y'all help me out. Natural log, let me start over. Natural log of what? Natural log of 43 over 2 times x to the 1/2. Like that. And then times what? Y. And that's y prime is equal to, and you can bring that y here, natural log of 43 over 2x to the 1/2. Yeah. And that's good enough for government work, just to get it in the y prime. That's all you need to worry about. Okay? And I'll give you some more of those in the homework. And the good thing about the homework is you can send me the homework problem and I can go over it or whatever. Don't get hung up. Do not spend 2 or 3 hours on a homework problem. All right? 30 minutes max. If you're going to spend more than 30 minutes on it, then stop at 30 minutes or 20 minutes or whatever. And what do? Go do something else and then come back to it. 9 times out of 10, when you come back to it, you'll figure it out in about half the time. All right? So don't fret. Don't go hammy on me and start going crazy just because one gets a little bit complicated. Remember your algebraic rules. Why do people fail Calculus 1? They don't know their algebra. If you don't know your algebra, then you're going to have a problem in Algebra 1 and Calculus 1 and Calc 2. All right? Calc 3, you ain't got to worry about it too much because you draw a lot in Calc 3. All right? Now, let's talk a little bit about antiderivatives. Antiderivatives. All right, tell me what the derivative gives us. What does the derivative give us? It gives you the equation of the slope of the what line? Tangent line. Okay, you good there? At any point. Not just the rate of change, but what kind of rate of change? Good job. Now, why is that important? Instantaneous, however you spell it, instantaneous rate of change. That's important because in calculus, especially in Calc I in physics, you don't want over a long period of time, you want the answer by what? Second, every single second. That's the difference between algebra and calculus. Calculus gives you the instantaneous rate of change, which means in Calc I, you've got a particle, and that particle is going up a helix type drawing, or y'all, can y'all see that? Y'all understand what that looks like, spring, okay? All right. And you want to know what the position vector is there, what the position vector is there, what the position vector is there, 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 and there. Now the position vector is going to be based on the origin, but it's going to be based also on the tangent line. Like that. And that's why you have to know tangent line. So the derivative gives you all that good stuff, Calc I. All right? So, hopefully you're discouraged now and maybe you'll walk out of school. All right. Now, antiderivative. Somebody tell me what it gives us. Nope. You're wrong. Quit school. It does. It does undo the derivative. It does. But what does it give you? Gives you the original equation. Did y'all see? This gives us the tangent line. I'm talking about graphically. What does it give you graphically? Area what? Area under a curve. Well, Huber, we could do that now. No, you couldn't. You could give me the area of a what? Shape, Huber. Yeah, that's right. You could give me the area of a shape, but if I asked you what the area under a parabola would, you'd go what? So, we're going to talk about area under curve right quick. Now, I do realize that y'all have gone over this. But remember I told y'all last week that I know that somebody in here didn't understand derivatives? Well, there's probably somebody in here that never understood this. Alright, so we're going to go over it. And then when we get through with the review, then we can go into the Calc II. You're going to have plenty of time to get discouraged. Alright? Now, let's change this. I want to change all this. I don't like this. Let's change all this to black. Alright. Now, if I wanted to find the area under a curve using algebra, then I could do this. I'll take my blue marker. And so on. Anybody with me? Problem with that is we got some gaps. So we need to take our orange marker All right, what's the problem using algebra? You're not going to get what? If you use algebra, you're not going to get a very what? Precise answer. All right, now what difference does that make? Well, it makes a lot of difference if you're buying land by the acre, doesn't it? If you're selling 120 acres and it's bounded on 3 sides by creeks, how do you figure the area? Kind of hard to do without. Now, if you have a calculator that does triangle over triangle over triangle, in other words, it just does a little bit of triangle, but basically doesn't. It uses a calculus theorem like this. Now, the old algebra, we take this length times this width, this length times this width or height, this length times this height. Then we take this height and this length, and then take half of that, this height, this. But we still take our red marker. No, let's take a red highlighter. No yawning in class. And y'all get the point. The red area is basically an error, or error, whatever. All right, so that's what we have. So we've got to either make smaller triangles, or make more triangles, or do something different. So rhyming comes into effect. Now, the basic principle behind rhyming is you take a purple box and you put it right here. Sorry. I get very emotional with the board. Okay? I get mad at it. And instead of having all these different shapes, you split your curve up into what? Bunch rectangles. Now you eventually start with these guys, but you see that they don't do us any good. So what you're supposed to do is you're supposed to divide these in half. Like so. And then what happens is you get eventually, you say to yourself, well, what's wrong with that picture? Well, that's not going to do it. We still have the triangles. So what you do is you break those in half. And what happens to the triangles as we keep breaking them in half? Okay? So let's make a comparison here. Tell me what my algebra is. What algebra are we using in this problem? Geometry. Length times what? Length times what? Everybody with me? And derivatives, the algebra was what? The difference quotient, right? Now we take this algebra and we add it, combine it with what? The limit theory. Well, in the derivative, how do we apply the limit theory? What did delta x or h or whatever you call it, what was h doing? It was approaching 0. Well, what are these? What are the widths? These widths are called dx. Okay? What are these widths approaching? Limit as x or dx or x, whatever you want to call it, approaches 0. Or what? Length times width. Well, the length is going to be whatever your line is. Okay? So that's going to be your function. And then what is your width? Or, I'm sorry, your length is going to be this is your height. I should say base times height. Your height is going to be whatever the function is, right? But what's the width going to be? Dx. Okay? Or width. But dx in calculus. So we're changing each one of these blue ones. Now you got to think out of the box now. You can't think redneck. You got to think out of the box. What do you mean, out of the box? We're not talking about 1/4 of an inch here. What are we talking about? These lines are getting about the width of what? A hair. Okay? Width of a hair. Half the width of a hair. Quarter of the width of a hair. Microscopic. But they're not what? Not touching. So you got to imagine these being half the width of a hair. That's Ryman's. This is Ryman's right here. That's Ryman's. Now what you're doing is you're taking each one of these heights, which is your f of x, and you're multiplying it by d of x, and you're doing the limit from 0 to 100. And that's how you do Ryman's theorem. But all you've got to remember is these two things right here. Let me change this. There. All right. Base is dx. Height is what? Now, the antiderivative basically says, let's say this is 0, and let's say this is 100. The antiderivative from 0 to 100 of f of x, what? Ryman's theorem, which tells you, take this guy. Sorry, excuse me. Let's say this first line is, let's say it's a ½ inch wide. And let's say it's, I don't know, this is a parabola, pretty wide parabola, so we'll say 1 over 15x squared. With me? So that would be 0.5, so antiderivative, well, no, we're not going to do antiderivative. Ryman, the summation of this guy, what's that guy right there? That's half, so 1/2 times what? Well, this function is 1/15 x squared. All right, you do that. Then what would you do? Then you move this guy. And what is he? He's a ½ inch. And you keep adding them and keep adding them and keep adding them. All right? Well, forget Ryman. I don't want to do all that work. Did you like doing all that difference quotient? All right, well, Ryman is a difference quotient. All right? They basically said, okay, forget that. Let's just do the antiderivative, which says my distance is going to be 100. And we're going to take the antiderivative of this guy, which will basically give us boom, 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 boom. You ever seen, I don't know if you ever seen AutoCAD work, okay? When you hatch something, actually, what are you doing when you're hatching under a curve? Doing this, not this. You're doing this right here. If you ever look, if you ever zoom in on AutoCAD, you'll see it goes up, and it goes down, and it goes up, like that. And that's what you're doing. You're doing the antiderivative. Now, of course, hatching is written by antiderivative algorithm. Okay? So, all you have to know is how to find the antiderivative, and you're doing Ryman's theorem instead of doing 1/2 times function times 1/2 times function times 1/2 times function plus 1/2 times function. That's Ryman's. Okay? So let's do one. Let's do something real simple. You ever seen the let's see if I can find it. I used to pull it up. The comic strip Foxtrot. Is it Foxtrot? You ever seen it? All right. Somebody tell me what Foxtrot is about. Anybody know? Okay, y'all. I forgot. Okay, let me look it up for you. All right. Mr. Fowler, please tell them that I call everybody losers. It's nothing personal. Yeah. All right. Foxtrot. Let's see if I can find it. Foxtrot. Fun. Finding area with there it is. All right, look at that. I'll try to blow it up for you. Hold on. Oh, horse puppy. I hate when people do this. Why don't they just blow it? Can y'all read that? Say again? Thank you. All right, let me blow it up now. Now, I used to pull this up in Calc I because it shows you the difference between algebra and calculus. So it says, word problems, nothing but word problems. Thank you. Farmer Bob's vegetable garden is 20 feet wide by 30 feet long. Calculates its area in square footage. Now, the algebraic way is to multiply length times what? Height. Or base times height, or length times width, whatever. Well, what is he doing? He's doing the antiderivative. Now, f of y is equal to 20. You got that. Y is equal to 20 right there. That's self-explanatory, 30 by 20. But what he's doing is he's taking little square roots, little rectangles, and this, and y'all say, oh, I can't believe you pull up the comic strip. Yeah, but you're going to see Riemann theorem that work like this. It's with a simple comic strip. Now think of this top line as a what? Curve. Now in this case it's not a curve. But what is the curve if it's a straight line? What is it? How do you write a straight line as horizontal? Y is equal to a number. That's right, class. Y is equal to a number. So what would y equal to? 20. Alright, so y is equal to 20. Why is y is equal to 20? Well, back in your algebra days, y is equal to 20. 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20. There's your y is equal to 20. Remember drawing a horizontal line? Now, area cannot be negative, right? Thank you, class, for being interactive. Appreciate y'all's interacting. So that takes care of that. And that's how he gets now you got to divide it up into little what? Little dx's. So, how do you set this antiderivative up? Well, antiderivative from where to where? 0 to what? Base 30. You're a loser. Of what? 20 is our f of x times what? And instead, let's divide these in half-inch increments. Can you imagine a half-inch? That'd be 20. What's 30? 60. That'd be 60 rectangles. That'd be 60 times that you have to add Riemann theorem. And it would be 0 to half. So 1/2 times 20, 1/2 times 20, 1/2 times 20, 1/2 times 20, and you'd add that how many times? 60 times. And that's right. So let's do the antiderivative of 20. So forget the 0 to 30. Let's just forget about that. So we got 20 dx. Well, if we apply the power theory, the power rule of antiderivatives, then that means this is in the x family because we've got to add an x. But what do? We add n plus 1 over what? N plus 1, right? Right? Or whatever. So what would that be? Well, right now, it's 20x to the 0 power dx, right? Do you know how easy things would be if you just wrote everything as an exponent in calculus? Whenever you get stuck, always write it as an exponent. X to the 0 is what? 1. Now, what do you do with antiderivatives? You add 1 here, and then what? Add that same thing, 0 plus 1 here. And what does that give us? 20 x to the first over 1, which is equal to 20 x to the first, evaluated at what? 0 and 30. What's 30 times 20? They know what? 600 square feet. What did he get? And he gets his quiz from last week. You see how easy calculus can be? But what happens is, students go in Calculus 1, half of them don't know their algebra, and then they get a teacher that just what? Lets it trickle, or do they just throw it at you? They throw it at you, and then what happens? You're totally confused. But it's really not that difficult. So let's do some of these. So you'll probably have 500 or 600 on your test and homework. Yes, sir. Don't stretch. Don't cough. Don't stretch. Don't. All you can do is breathe in here. Okay. All right. So let's do some antiderivative problems. Now, what is a finite derivative and what is an infinite derivative? I mean antiderivative. Sorry. Why don't they call it integral? Why do they call it antiderivative? You have some teachers that have a cow and you call it an integral. Then you have some teachers that don't care. I don't care. Antiderivative, integral, it doesn't matter. Some people say the integral is from 0 to 100. The antiderivative is when you don't have parameters. I don't care. All right? So, have you ever had a teacher that had a fit if you called it antiderivative? Or have you ever? Okay. They will. Just like if you have a probability of statistics teacher that has a fit if you say 50% chance. You ever had one of those? Okay, you're not going to talk to me. Okay. That's fine. Huh? You never had it? You didn't miss nothing. It's underwater firefighting. All right, let's pull up, what do we call it? Antiderivative. Let's pull up one of those. Derivative rules. Let's look up rules first. There we go. There's a good sheet right there. All right, there's your power rule. There's your natural log. There's your dang old trigonometric functions. That ain't what I want. That ain't, well, we can go ahead and work on those. Let's go ahead and do a worksheet problem. Antiderivative worksheet. Go. Alright, I don't understand why I can't go up and down. What's wrong with this thing? Okay. Find the indicated, I thought I said antiderivative. Did I not say antiderivative? These people are losers. Antiderivative worksheet. Oh God, somebody uses omega. Really? Whatever. Okay, I'm not going to use omega. I'm sorry, I'm not going to do it. So let's go ahead and do a couple of the odd ones. Let's do 1, 3, and 5. Go ahead and work on those. 1, 3, and 5. 1 says find the antiderivative of square root of 2 dx. better blow it up some more because they can't type the other way, can they? Oh. There, how's that? Is that better? You're just going to have to do 1 and 3 right now. We'll get to 5 in a minute. What I'll do is I'll put a couple of rhymings on the homework, and we'll go over it together whenever everybody's had a chance to work on it, okay? Radicals in calculus, what? Don't mix, Hubert. That's right, class. So, antiderivative of 2 to the what? 1/2, Hubert. That's right, class. dx. So, really, what are we going to do? What are we going to do to it? I'm sorry, what? Yeah. Why didn't it have an x in it? Okay. It's going to be, it's just like taking the antiderivative of 3 dx would be what? Because what is x right now? See, and that's an example I was telling you. If you get on a test and you just do it, you ever done that before? Stare at a problem before? And you think it's going to stare, if you stare at it long enough, it's just going to balloon out to be a, you need to rewrite it. So this is what I suggest you do. Antiderivative of 2x, what? To the 0 plus what? 1/2. You could write it like that if you want to. Alright? Or, I'm sorry, 2 to the 1/2. Sorry. I messed up. There. How about that? X to the what? 0. Yeah. Now what can we do with all constants, with derivatives and antiderivatives? What can we do? Pull what? Pull it out, right? I can pull that 2.5 where? Out front. Why do you do that? Makes it easier. And when you get to Calc I and differential equations especially, if you see a constant, the first thing you do besides change a radical to an exponent is pull all that out. So pull all that out, you get 2 to the 1/2 power times the antiderivative is x to the 0 dx. Now you're ready to take the antiderivative. And that's plus 1 here, and plus 1 here. And that's going to give us 2 to the 1/2 power times x to the 1 over 1, which is 2 to the 1/2 power x plus c. Don't forget the c. You've got some teachers that have a cardio infarction about the c. Don't forget the c. Alright? And of course, 2 to the 1/2 is square root 1.41. You can write it several different ways. You can write 2 to the 1/2 x plus c. You can write it 1.41 xc, dot, dot, dot. You can write square root of 2 x plus c. Alright, let's try number, what did I say, 3? That's 3t to the negative 7 dt. What am I going to pull out? Now you just take the derivative by your power rule. And that's going to give you negative what? 6. T to the negative 6 over negative 6. 3. Negative 6. t to the negative 6. Y'all help me out, make sure I don't make a mistake. And what can we do to make this a little bit nicer? Be 1 over what? 2 to the what? Y'all check and make sure I didn't mess up the exponents. Now let me ask you a question. How hard is that concept? Not hard at all. But if you don't know the algebra, to flip it up and down and do all that other stuff, you're going to be lost. There's an old saying. And the old saying is, you got to crawl before you can what? There ain't no walking before you crawl. And if you don't know the algebra, you ain't going to learn to count. You ain't going to learn. There's a difference between ain't going to learn and going to learn. Difference. Ain't going to learn means you lost. Just like a whooping and a whip. There's a difference between whooping and whip. Right? Some of y'all like, what's a whipping? Nothing. There's a difference between naked and naked. Naked is when you're back there. Naked is when you're doing something you ain't supposed to be doing. Alright, Kyle. Antiderivative of 3x to the negative 2/3 dx. What? Alright, what's the difference between whipping and a whooping? Yeah. A whooping, you either got stripes on your legs, you got a bloody nose, or you just got your foot whoop, and whip. Two different things. Alright, what are we going to do? That's not rhetorical on that side. Take the 3 out. Now a lot of calculus too, we're going to be going in depth. You know how you went in depth with the product rule and the chain rule and stuff like that? But on Calc 2, you're going to go in depth with the integration. I'm sorry, integration. I love to do that. That really throws some people off when I do that. Especially in Calc 1. Well, where did that 3/3 come from? I have no idea. I'm just pulling it out of here. Alright, what is this? X to the 1/3 over, and that's 1/3 also. So 3 divided by 1/3 is the same thing as 3 times what? 3, which is x to the 1/3 plus. Now what's the only calculus in this problem? Right here. There's your only calculus. Actually, that's incorrect. This is your only calculus. The rest of it's what? All right, let's do one that somebody would go hammy on. Y'all know who hammy is, right? Okay, so make sure. Okay, that's right, brother. Let's go ahead and do number 7. Do number 7 and 8. A 7 and 8, that'll make you go into hysterics. Oh my God! All right? They're not that big a deal. The antiderivative of 3 over square root of t dt. What's the first rule you need to think about doing? 2 of them. Okay, fix this. This is oil and what? I'm sorry, OIL. Pronounce however you like. This is OIL and water right here. Calculus and radicals don't mix. Change that and do what? Pull the 3 out. And we get the antiderivative, 3 times the antiderivative is dt over t to what? 1/2. Say again. Use your algebra. Now, whether that t to 1/2, just use your rule. 3, and that t to the negative 1/2 plus 2/2 over negative 1/2 plus 2/2 plus c. And that's going to give you 3 t to the 1/2 over 1/2 plus c. 2 times 3 is what? And you feel good about yourself. It's not hard, is it? If you know your algebra, you take your algebra and your calculus, put it together. There's nothing. What's difficult about the calculus? What did you do with the product rule? First times derivative of second plus second times derivative of first. What's hard about that? What's hard about this? Nothing. One has a lot to do with what the student knows about algebra and has a lot to do with how it's presented. This make you go hammy, but what do? Take the antiderivative, 1 du plus the antiderivative. Y'all supposed to go into cardiac arrest. Sorry about that. It's supposed to come in on my... Okay. Decline. Sorry. There. Break it up into 1 du, u du, plus what? U squared du. Now you just got, instead of one problem, you got 3. So, what's the antiderivative of du? U. U squared over 2 plus what? Okay, I don't care. Because Webassign, what does it put on there? It puts a little C outside. I'm not going to mark. Okay, I'm not one of these teachers. If I was giving you a hard copy test and you had the answer to a big long problem and I marked and you didn't put the C, I'm going to mark the whole thing wrong? No. That's ridiculous. Now, if I wanted to be astringent, I would probably take a half point off or a point off. But take the whole thing off, that's stupid. And I'm sorry if your mom and dad's a teacher and they do that, they're stupid. I'm sorry. It is. I mean, how much of the problem did you do right? All of it, except for one little bit. And what does that tell you? It tells you that it's in the family of x squared. It's in the family of x squared plus 2. It's in the family of, it's not a big deal. Especially if you fail. I don't think so. And I didn't mean that about your parents, I was just kidding. All right. Y'all need to lighten up. Okay? All right, let's do some definite intervals. So then y'all can get discouraged about you can't do math. All right? And I'm just trying to discourage you can't do algebra. Now, let's see if I can discourage you by not being able to do math. Yeah, just regular old mathematics. I can't find the daggum page I was on. Oh well. I suck. Let me just go to another. Let's do definite antiderivatives. I don't know how to spell definite. Is that right? That gum. That handwritten stuff. All right, let's do 1, 2, and 3, and 6. Let's do 1, 2, 3, and 6. We'll do the trig when I get there. We're gonna do them. Don't worry. You can just hand me the hammies. You just wait. Oh, I'm sorry. You need to. Oh my Lord. Oh. Where's the dadgum? There it is. How's that? Is that better?
Look at it again.
No, I don't want to mess it up. I'll just there. I'm not going to touch it. One, I got to go up. There we go. 1, 2, and 3, and 6. Now tell me what time it is. We'll go ahead and take the attendance so y'all can run out of here like a bat out of Hades. Alright, y'all are math 141. Okay, Mr. Alexander. Okay, Mr. Bowling. Mr. Corwin. Mr. Fowler is here. Mealer. Oslin. Robinson. Robinson. Was that? No. Urban was here. He left a message. Vaughn, Williams, and Wiseman. The only person not here today is Mr. Robinson. No, I got his name. His is Mr. Urban. Dang old Rule and Urban. This is Mr. Robinson, as in Jackie. All right, save. Alright, I'll go ahead and start on the first one. Antiderivative. Yeah. Antiderivative from 1 to 3 of 4 dx. So pull that 4 out. 1 to 3 of dx. Okay, I'll do this one because it's pretty tough. the antiderivative of dx is x, evaluated at what? 1, 3. Now here's where you suck it. You either suck at math or you don't. You plug that in, and then you subtract because you're evaluating at 4 times 12. And 12 minus 4 is. Now, let's go back, and I'm just reviewing this right quick. Let me ask you a question. If you go to Greenville, if you go to Greenville and you leave from Anderson, and you don't have any idea how far it is, how do you ascertain how far you've driven? Well, you take this and you subtract what? This. Well, in this case, it's 0. That's where the evaluation comes. You always what? Subtract. You always subtract. Okay? Again, I'm not doing it to insult your intelligence. I'm just doing it to kind of just not cobweb. Just curious. How long has it been since you had Calc I? 2 years. Less. 2 years. Huh? Okay, so we've got 2 people in there that in 2 years. It gets rusty, doesn't it? Not to mention the algebra. All right, let's do the next one. Number 2. I'm going to go black. All right, so antiderivative from 5 to 2 of x squared dx. Now you can actually picture this. X squared is a regular parabola, correct? Like that. And you're going from 5 to what? 2. So you're finding that area right there. Now this is feet. 2 feet and 5 feet, then it's square feet. It's miles, square miles, blah, 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 blah. So x to the what? Evaluated at 2 and 5. Parentheses cubed over 3 minus parentheses cubed over 3. Now, the more difficult your functions get, the more you need to rely on these guys. Now, this is where we get into some people have a little bit of NASA engineer syndrome. They don't use those. They don't know how to do it. Don't cry when you get that problem wrong because you got a negative 8 and it's supposed to be a positive 8, or you got a negative 1/8 and it's supposed to be a positive 1/8. That's what the parentheses are for. Use them. I still use them, and I got 2.5 degrees. Actually, 3.5 degrees. All right, so what do you get here? Well, 5 goes here, and the 2 goes here. All right. What's 125 over 3? Well, for a doesn't work, 125 over 3 is 125 over 3. We're not going to worry about it. Because we don't want to have to depend on a calculator because that makes us stupid. All right. 2 cubed is what? 8 over 3. What's 125 minus 8? Dang old 117? Y'all check my math. Now you can change it to 39 even. So 39 square feet, 39 square millimeters, 39 square units under that curve. 39 acres. Dang old, got a road here, Hang on, we got a road here. Oops, sorry. There's a road there. Got a road here. Got a road here. And got a bridge here. Creek on it. 39 acres. Now, how wide, that's, you're talking about probably, what, 300 feet here? 300 by whatever that is. Be more than 300 feet. Yeah, probably 300 feet. All right, next one. All right. 6(2). Of x to the -3 dx. Do not make fun of my mouse drawing. So I will make you come up here and you will draw with the mouse and everybody make fun of you and then you'll quit school and live in a ditch. Okay? I was saying living in a ditch before Direct came out with living in a ditch. I was saying that a long time ago. Y'all ever seen that commercial?
Yeah.
Where the guy loses all his money or his hair and he lives in a ditch or something. I don't know. Freddy versus Jason was one of my ideas too. But they took it. Anyway. Who's Freddy? Alright, x to the -2 over what? Evaluated at 2 and 6. Well, we're going to plug in that 6 there, or we're going to move that. I'm going to move it. Because if you plug the 6 in right here and the 2 in right here, then you'll go into Patrick Starfish. And just stare at it. Don't do that. 1 over 2x squared, evaluated at 6 and 2. Sometimes I do that. It just has to be work. So that's going to be 1 over -2, 6 squared, minus 1 over -2, 2 squared. And 6 squared is 36. Then go -1 over 72. Uh-oh. Plus, negative and negative make what? Positive. 1 over dang old what? 16? Somebody check me. Oh, I'm sorry. I thought that was a 3. My bad. I was just making sure y'all were awake. Dang old, what is this? 9, dang old, 9 over what? 72? I get 8 over 72, which that can be reduced to what? Dang old, 2 over 18, which is what? I don't know. Somebody help me out. 1 over 9? Huh? 1 over 9? Well, that sucks. 1 over 9. All right, try number 6. That'll cause you to go into procedure. Tell me why. Negatives. Oh my God. Just tell me. I'm just telling you what students do. I'm not telling you you're going to do that. I'm just telling you what students do. Let's see those negatives, and they go into what? Huh? Yeah. I know. Some people just have fits. Actually, it'd help if you drew it. What's y equal to? I don't like this notebook paper here. I'm going to rewrite it. What's the, y'all going to have to help me out. All right, what is antiderivative of what? -1, -4. Of what? 4? dx. Well, isn't this just like the cartoon? Y is equal to 4 instead of 20, right? Yes, Hubert. Thank you, class. So you basically got y is equal to 4. 1, 2, 3, 4. Got a y. And we're going to go from negative 4. 1, 2, 3, 4. To what? So you're talking about an area of a what? Thank you, class. Actually, it's a it is square. It's 16, right? We'll see if y'all can screw it up. I'm sorry, get it right. So what is it? 4 goes out. Negative 4, negative 1 of what? Dx. And that's going to be 4x. Evaluated at negative 1 and negative 4. And which one's A and which one's B? Which one's greater? Negative 1. Okay. 4, negative 1, minus what? 4 times what? Negative 4. Oops. And what does that come out to be? What's 4 times negative 1? And I'm supposed to subtract, I did subtract, but that becomes what? And what does that come out to be? And that comes out to be 12. I thought y'all said 16. Huh? Yeah, it's only 3. Be careful with it. Okay? So you feel good about yourself? So you don't have to put smokestacks on your truck? Right, Mr. Fowler? We had a guy here one year had smokestacks on a Ranger with a 4-cylinder.
I know a guy had a Nissan like that. He put the tractor tops on it. And he pulled into the parking
You know what
lot.
those are called? Butterflies.
Butterfly. And every day he pulled into the parking lot and he revved it up and go ding, ding, ding.
Somebody should have shot him. Shot the tires out, not him, but shot the tires out. Do you know what smokestacks are originally for? See how smart you are. How'd you know that? You're supposed to say Hubert told us last year.
I don't know.
In the 60s and the 40s and the 50s and 60s, the transfer trucks had exhaust coming out of where? Just like a car. So when you pull up at a red light, we didn't have many air conditioners back then. What would happen? You get fumigated. So they put the smokestacks up high so they'd go out. That's the only purpose for them. I get more horsepower. No. You're overcompensating. You need to take them off. All right. What's overcompensating? Forget it. All right. Try number 8. And then we'll look at a couple of, I'm sorry, antiderivative from 0 to 9 of x to the negative 10 dx. Antiderivative from 0 to 9 of x to the negative 10 dx. All right, what's the first thing you need to do to make this problem easy? What? Okay, you don't have to. You don't have to put the negative 10 downstairs. You don't have to do that, but some people would. I would just go ahead and take the negative 10 and add 1 to it. Negative 9 over negative 9, right? I don't care how you do it. You do whatever you want. That's going to give us x to the negative 9 over negative 9 evaluated at 0 and 9. Well, I'm going to do 0 for you. I'll do that for you. And that'll give you what? 0. You like to get zeros, don't you? Yeah, Hubert. Yeah. All right, so what are you going to do with that 9 to negative 9? You're going to break it downstairs. That'd be 1 over 9, negative 9, x to the negative to the 9th. Sorry, x to the 9th. So dango, put the 9 in there. It's going to give you a very, very, very SA number. 9, and I'm not even going to try it. So unless you're Rain Man, knock yourself out. You're talking about a very what? Small number. Very small. Okay, so let's look right quick at some of your, let's look at that thing you bring to class, book. Yeah, let's look at that. Dadgum, is it already time to go? I thought we got it out at 10. Okay, I just wondered. All right, chapter 5. No, chapter 5 is in antiderivatives. And I think we just covered 5.1 and 5.2. So right now, you're talking, what are you good for? Let me just write it down for everybody, and I'll start putting some homework up probably this afternoon. I'm going to write this down for you. Sorry, I'm just going back and forth. Right now, you should be, let's look at one more thing. Right now, you should be looking for homework. I will post homework today on chapters 3.1 through 3.6. I think logarithmic differentiation, and 5.1 through 5.3. Yeah, at least 800. No, you're probably talking. Well, there's some things I will probably give you a lot of, like the chain rule. I'll give you a lot of the chain rule because the chain rule is essential. You don't have the luxury of doing Patrick Star on a test. Okay, you need to know how, and most of y'all know how to do the product rule and the quotient rule without any problem. But the chain rule, some of y'all try to steer away from it. That's not an option. So the chain rule, instead of 20, you might get 20 or 30 on the chain rule. Okay? All right, y'all get out of here. Have a good day. And I will try to get that thing downloaded. I'm going to do that right now when y'all leave. I'm going to try to do it with my phone. We will, I'll download this video up here today. I'll do that right now. Now, do you want 1,200 problems? I'll do 1,200 if you want to.